Again, this is Professor Zawglo, and today I'm going to be going over Section B, which is Algebraic Processes of the West African Examination Council Senior High School Certificate Examination Mathematics for Liberian schools. Under Section B, we'll be dealing with subsection H, which is algebraic fractions, and we'll be addressing the objective, which has to deal with performing operations on algebraic fractions with binomial denominators. This is the second in a series of 2 videos on algebraic fractions. So I think we understand what are algebraic fractions. So we're going to go into actually working with algebraic fractions with binomial denominators. So again, we can do some of the same things we did with algebraic fractions involving binomial denominators. So we have a listing, we can add, subtract, multiply, divide. When we add and subtract, we must find the LCD. When we multiply, we must cancel common factors. When we divide, we must multiply by the reciprocal. We must express our answer in simplest form, meaning that the denominator and numerator of our answer cannot have any common factors. So let's now try some problems. So the first problem, the first example we have is a basic example on simplifying, basically simplifying. The concept we have to use here is the concept of factoring. So when we look at our numerator in example number 1, we see that y is common to both terms in our numerator, yeah? So I can factor out the y, and then I will have x minus y over, at the bottom I have x minus y squared. So if you look at it carefully, x minus y squared are basically the same terms. So what's going to happen is that this is going to cancel, and the square component of this is going to cancel, and our result will simply be y over x minus y. Easy, very simple. That's how we do a problem like this. Let's now move to problem number 2. So problem number 2, again, we have to simplify. One of the things we observe here is that our numerator has not been written in the order of descending powers of our variable x. So let's try to see if we can change it. Let's rewrite this as negative x squared minus x plus 12. And then we see that our denominator is basically the difference of 2 squares, which factors into x minus 3, x plus 3. Now, if you have any problem, just recall x minus y, x squared minus y squared is basically x minus y times x plus y. It's the very concept we're using to factor the denominator. Another thing we can do in our numerator is that we can factor out the negative, and that is going to change the sign of every term on top. So instead of negative x squared, we'll have x squared plus x Let me do that again. I'm going to have x squared plus x minus 12 over x minus 3, x plus 3. Now, so we can factor out the numerator up there by looking for 2 terms. We can multiply to give us 12, negative 12, and combine to give us a positive 1. So we see that that's going to be x plus 4 times x minus 3 and why is this so? Because 4 times negative 3, 4 times negative 3 is negative 12, and 4 plus negative 3 will give us 1, which is basically 4x plus negative 3x will give us 1x, which is what we have over there. So seeing here, we see that x minus 3 is in the denominator, x minus 3 is in the numerator. They're going to cancel, so we're going to be left with basically negative x plus 4 over x plus 3, and then we are done. Now let's go to do more challenging problems involving multiplication, division, addition, and subtraction. Several things we have to take note of. Again, it's fractions, so we must multiply by the reciprocal. Secondly, we have to factor. Now, the order in which you do it doesn't matter, but I think what I prefer to do is to multiply by the reciprocal first. So I'm going to rewrite this as x squared minus 7x plus 10 over x squared minus 5x plus 6 times x squared plus 8x plus 12 over x squared minus 3x minus 10. And then I have to factor on top. So on the left side here, in the numerator here, I'm looking for two numbers I can multiply to give me 10 and combine to give me -5, -7. So I can see that's x minus 5, x minus 2. Because -5 times -2 will give me 10, and -5 plus -2 will give me -7. In my denominator, I can do the same thing. So I'm looking for two numbers I can multiply to give me +6 combined to give me -3. Those two numbers must have the same sign. There must be a negative since we're looking for -5. So I know it's -3 and -2 because -3 times -2 is +6. -3 plus -2 is -5. Then I have times. And yeah, I'm seeing that it's going to be basically 6 and 2, x plus 6, x plus 2, because 6 times 2 is 12, and 6 plus 2 is 8. Well, in the denominator, we must have opposite sign to get a -10. So let me structure it like this, x, one negative, one positive. Which one comes first? Doesn't matter. So 5 times 2 would be 10, and -5 plus 2 would be -3. So it's this. So -5 times 2 is -10, -5 plus 2 is -3. Now we look for common factors within the numerator and denominator and cancel them. So the first one I'm seeing is x minus 2 is in the denominator, x minus 2 is in the numerator. That's going to cancel. I see an x plus 2 here in the denominator. I see an x plus 2 here in the numerator. I see an x minus 5 here in the denominator. I see an x minus 5 here in the numerator. So what am I left with? I'm left with x plus 6 over x minus 3. Common confusion is, can we cancel the x? Absolutely never. No, you cannot. You do not know the value of x, so you cannot cancel out in this case. Very easy, simple process. Let's try another one. Again, we have to divide. So let's begin by first multiplying by the reciprocal. So we do times 2 minus x over x plus 2. Now, when we look here, it doesn't appear that we have common factors within the numerator and denominator. But if we look over here, we could do something so that this can be 2 minus x. So if we introduce a negative to this, we can change this now into what? So this becomes negative x plus 2. So this becomes, I keep the negative outside, this becomes simply 2 minus x. So when we keep that negative up there, we haven't really changed anything. So it's still the same, but by introducing that negative and keeping it, it allows us to cancel. So that's what we're going to do next step. And we could have also put the negative over here. So we're going to keep this as negative x minus 5 over x minus 2 times 2 minus x over x plus 2. Now, or I can say this. This becomes what? 2 minus x. Remember, keeping that negative says that if I apply the negative again, I'm going to have negative 2, which is this, and I'll have positive x. So now what happens? It's negative 2x, and that would cancel. So I'm going to have as my answer negative parenthesis x minus 5. It was good to put a parenthesis here. Over over x plus what? Over x plus 2. I must indicate here clearly that this technique is extremely important in solving a lot of problems on the WAEC when it comes to adding algebraic fractions. Let's move to the next one. The two denominators, x minus 2, x minus 3, x minus 2, x minus 3. Now, so our denominator was x minus 2. X minus 2 divided by that will give us x minus 3. So we're going to have 5 times x minus 3. And one of the things you can see that by introducing this denominator, introducing this in the numerator, we just cancel out and we'll go right back to our problem, which indicates that we are right. X minus 2 will cancel x minus 3. We had a 1 here, that's going to be x minus 2. So if I cancel that x minus 2, I think our if I cancel the x minus 2, I'm just left with 1 over x minus 3. So that's good. Now let's perform the operations on the numerator. So I have 5x minus 15 minus 1x plus 2 over the product of x minus 2, x minus 3. So let's combine like times. 5x minus 1x, that's going to be 4x. 4x minus 13 over x minus 2 times x minus 3. And there's nothing more we can do here, so that's our answer. Let's try another one. X minus 2, that was going to cancel, I'll be left with this. So I multiply the numerator by this, the same thing here. This would cancel with that, I'm going to be left with x minus 2. So I'm going to multiply this numerator by 3x minus 2. So we're going to go over there. Negative 6 times 1, that will give me negative 6. Negative 6 times x, that will give me positive 6x. 3 times x, that will give me 3x. 3 times negative 2 will give me negative 6. Okay? And then I just write my numerator, which is my denominator, which is x minus 2 over 1 minus x. Now let's see what happens in the numerator. Do we have like terms? Yes. 6x plus 3x, that will give us 9x. And negative 6 minus 6 will give us negative 12. Ooh, let's see whether we can do some other stuff. Yeah. We don't know yet? Let's see. I don't think so. 1 minus x. Now, I can factor out 3x from over 3 from over there, 3x minus 4. Not going to give us anything different, so we can just keep our answer as that. Alright, we have I think 2 other problems. Let's go ahead and do them. Now, in this case, we have to factor up. We have to do some factoring in that numerator to write it as a product of linear factors. So this is the difference of 2 squares over here. 2x minus 3, and this is going to be x minus 3, x plus 3. Don't try to cancel. Let's keep it just like that and work. So what's going to be the LCD? LCD will be the product of the distinct factor of the numerator. How many different factors do we have in the numerator? X plus 3 and x minus 3. So our LCD is x plus 3 times x minus 3. So we're going to rewrite this problem like that. So we're going to do x plus 3, x minus 3, plus x plus 3, x minus 3. Now let's go back and see. So x plus 3 into that will be left with x minus 3. So we have 3 times x minus 3. So plus sign here. Then x plus x minus 3, x plus 3 into that is going to be 1. So we're going to be left with just what? 2 times x minus 3. So let's do the operation on top. That's going to be 3x minus 9 plus 2x minus 6 over x plus 3, x minus 3. So do we have like terms on top? Yes, 3x plus 2x, that's going to give us 5x. Negative 9 minus 6. That's going to give us negative 15 over x plus 3 times x minus 3. Now we can factor on top here. We have 5x minus 3 here. And then we have x plus 3, x minus 3. And we see that x minus 3 can cancel. So our answer will be 5 over x plus 3. Okay? Basic. Factoring, finding least common denominator, combining like terms. Let's take on another one. Well, it appears that one of the fractions here doesn't have a denominator, but it indeed has, because you can make that denominator to be 1. So we have all prime factors in the denominators here, so our LCD will be the product of these prime factors, which would be y minus 2 times y plus 2 times 1. Kind of redundant, irrelevant to do. So now I'm going to rewrite each fraction here with that denominator of y minus 2, y plus 2. We have 3 fractions, so let's do that. Let's write all of them in that form. So the second fraction will also have the same denominator, x minus 2, x plus 2, minus x minus 2, x plus 2. Now, let's go. For the first fraction, if we divide y minus 2 by this, we'll be left with y plus 2. So we have y times y plus 2. And then for here, y plus 2 will cancel with y plus 2. I'm sorry, I used x instead of y. These are all y's. So the y plus 2 and the y plus 2 will cancel. I'll be left with that. So I'll have y times y minus 2. And for this, if I divide 1 into that, I'm going to be just having the same thing. Y minus 2, y plus 2. Now, let's do on top. We're going to do the distributive property here. So I'll have y squared plus 2y minus y squared minus 2y. Now, I'm going to do this first. I'm going to do minus 5, and I'm going to do y minus 2 times y plus 2 is going to be basically y squared minus 4. And I'm just going to write a denominator once. Let's see if we can cancel terms over there first before I even do the end. Y squared minus y squared will be 0. 2y minus 2y will be 0. So on top I have negative 5y squared plus 20 over y minus 2 y plus 2. Now another interesting thing is that I could have just kept my negative 5 out, and let me do that, and then factor that as y minus 2 times y plus 2 over y minus 2 times y plus 2. And what do you see? Cancel. So my answer is just going to be negative 5. Okay, let's try another one. Okay, similar thing. I can factor right here, so let me do this. It's going to be a minus b times a plus b. So once we've done it for a while, we can begin to stretch our imagination a little bit, or our thinking a little bit. So these are my factors. A denominators, a minus b, a plus b, a minus b, a plus b. So the product of the distinct factor here will be a minus b times a plus b. So that's going to be my least common denominator. And then we can begin to cancel. A minus b will go in here. We left a plus b. So I do a times a plus b. A plus b will go here. We left a minus b. So it will be 2a times a minus b. And a minus b would cancel with a. And so I'm going to be left with what? 2ab. So now, let's see if we can do some multiplication. It's going to be a squared plus ab minus 2a squared plus 2ab minus 2ab over a minus b, a plus b. Now let's see what happens on top. I have a squared and a squared I have a squared minus 2a squared. That's going to be negative a squared. And then I have ab plus 2ab. That's going to be 3ab minus 2ab. That's going to be what? Plus what? ab over a minus b times what? A plus b. Now let me see something. Let me factor out a negative a out. I'll be left with a minus b over a minus b times a plus b. So a minus b will cancel. I'll be left with basically negative a over a plus b. And that will be my answer. Now we have a last problem to do. Let's stick on that. Okay, let's do our last problems on this section here. So one of the things here we need to do is to find our least common denominator. So the least common denominator contains the variables what? A, B, and C. In none of these denominator is there as any one of them being raised to a power more than 1. So basically our least common denominator would just be A times B times C. So let's go ahead and rewrite each problem here using that as our denominator. A, B, C plus A, B, C plus A, B, C. So now, if I take B and put it into that, I'm left with AC. So I have here AC times B minus C. If I took AC and put it into that, I'll be left with just what? No, sorry, I think I made a mistake first. If I take, let me just go back here. If I took BC and put it into that, I'll be left with only A. So I have A times B minus C. If I took AC and put it into this, the A and the C will cancel. I'll be left with B. So I have B times what? C minus what? A. And if I took AB and put it into here, I'll be left with C. So I have C times A minus B. Now I want to write my denominator once and do the operation on top. So I have AB because A times B minus AC plus BC minus AB plus AC minus BC. CB is the same thing. I could just stuck to the convention of calling it BC. Well, I see here that AB minus AB will be 0. AC minus AC will be 0. Likewise, BC minus BC will be 0. So my numerator becomes 0 over ABC, and 0 divided by anything is a big 0. So our solution here is 0. So basically we're done with adding and subtracting algebraic expressions containing binomial denominator. We did 10 basic examples on this. So visit us online, subscribe to our YouTube channel. Good luck on your preparations. Thank you.